Hello everyone, my name is Johanna Beyer and I'm a research scientist at Harvard University. In this video, we will talk about how we use the concept of design sprints for teaching visualization classes. Design sprints are originally a guided 5-day process where people work in small teams to quickly build up and test ideas. A design sprint contains 5 distinct steps that teams work through together, so that it's a very hands-on learning approach. And the reason that we use design sprints is that they very closely match our teaching ideology. So why is that? First, design sprints are learner-centered. That means a sprint uses techniques from active learning where the focus of activity shifts from the teacher to the learners. So students don't just sit and listen to a lecture, but they actually have to directly apply their newly gained knowledge. Also, active learning has been shown to engage higher order thinking tasks such as analysis, synthesis, and evaluation. And all those tasks are very important for designing effective visualizations. Second, design sprints are project-based. That means that they focus on cooperative learning, where students work together in teams and learn from each other. This is especially useful in a classroom full with students of diverse academic backgrounds. Our VIS class is typically popular with CS students, but also with students from the School of Design, Data Science Masters, or even students from the School of Education, Government, or the medical school. In addition, project work really enables learning by doing, where students can directly apply concepts learned in class. And third, design sprints are well-defined and time-constrained. That means a design sprint consists of 5 clear steps that, on the one hand, map well to visualization projects, and on the other hand, it allows instructors to split up a big project into smaller, manageable steps. We have used design sprints in several different settings, and they have proven to be quite versatile. So in the remainder of this presentation, I want to talk about how we have adjusted design sprints to fit our visualization classes. We have run design sprints both for in-person classes as well as in online settings. And we've run it in different lengths, from semester-long courses to 2-day workshops. In particular, we will talk about some guidelines and some pitfalls to avoid. And we also want to point you to our teaching material, which we have made available online. So let's start by looking a little bit into more detail what a design sprint is. In short, a design sprint is a process based on rapid prototyping and user testing, where a team works together to quickly generate some initial results. In contrast to hackathons, however, a design sprint is well-defined with distinct steps, and it is also time-constrained. So here are the main steps of a design sprint. The first step is called map, and it's all about mapping out the problem space, setting a goal, coming up with questions that need to be answered to achieve this goal, and so on. In a visualization project, this step includes asking questions like, what is the data? What is the question? Who is the audience? The second step is sketch, which is the ideation phase, where participants individually come up with many different ideas. In a visualization project, that would involve sketching visualizations in pen and paper. Each person then picks their personal favorite and refines those sketches a bit. Which brings us to the next step, which is decide. So here teams work on reaching consensus on the best solution that they have sketched before. They look at all the sketches, discuss them, vote on best sketches. In a visualization project, they might cluster visualization sketches based on what question they answer and discuss visual effectiveness or how visualization sketches could be improved. The highest rated sketches can then be combined into a dashboard. The prototyping step is meant for teams to really build prototypes of their ideas. This is typically the most time-consuming step in a design sprint. In a visualization project, for prototyping, we typically either use Tableau dashboards or D3 and ask students to build an interactive storytelling website. But we have also done design sprints before where students just used pen and paper for prototyping. The final step is user testing. Here the goal is to test a prototype with 2 to 5 users and to collect their feedback in user interviews. So that's the design sprint in a nutshell. So before adding a design sprint to your VIS class, you should ask yourself, why? Well, in addition to the positive aspects of active learning and group-based projects, design sprints are just a lot of fun, not just for students, but also for teaching staff, because they get to mentor project teams and see what comes out in the end. And second, we feel that visualization design sprints really combine the aspects of visualization theory, design skills, and coding skills, which are 3 main learning goals in our visualization classes. So now that I've hopefully convinced you about why you should include design sprints in your classes, how should you do it? So there are 4 main considerations, but let's look at them individually in a little bit more detail. Decide on the length, scope, and difficulty on a design sprint. You can make a design sprint last an entire semester, or you can fit it into 2 days. You can have a very guided sprint where you help students a lot, and you can have a more independent sprint. For example, you can give them already a clean data set and specify the audience for their visualization, or you can let them program in D3 or Tableau or use pen and paper prototypes. So it's really up to you to set the scope and difficulty. Second, plan how you will give feedback. Frequent and immediate feedback is very important. If you have many teaching assistants, they can walk around in class and provide live feedback. If you only have a few, you can use peer grading or written feedback. Generally, we've found that having a project mentor really helps students in longer design sprints. And third, plan how you will assess the design sprint. We tend to have weekly submissions in our classes, which allows to track students' project very fine-grained. We also ask students to evaluate each other within each team to see if all of them are pulling their weight. And it also motivates students to make sure that they put in enough effort into their group project. We also avoid best project prices, which seem to be a main motivating factor for many students, but also for teaching assistants. And finally, if you're doing online design sprints, make sure that you carefully plan out all steps of your sprint and how they will translate to an online experience. Online students do much better with clear written instructions that they can look up before and during the sprint. So goal descriptions, links to datasets, links to tools, collaborative online tools, a table with all deadlines, and so on. We've also found that online instruction and collaboration just takes a little bit longer, so the sprint might have to be reduced a bit in its scope. For more details, please check out the paper. Now I just want to show you some examples of how we've used design sprints in our classes. Here's an example of a guided sprint in the first half of a semester-long undergraduate class. The idea here is to have students work on the sprint at the end of each lecture at least once a week. So every week they work roughly through one step of the design sprint, or maybe work on the same step for 2 weeks. And we used this guided sprint to teach them how to run a design sprint, and also to give them a solid support structure where most of the work is done in class and teaching staff is always around for help. We typically provide them with a clean data set and a description of the audience for their visualization project, and we ask that the end result is a Tableau dashboard. The next example is a final project in our undergraduate class, where students work on a project of their choice in the last 5 to 6 weeks of class. They still follow the design sprint process, but now most of the work is done on their own outside of class. We still have weekly submissions to track their progress and provide timely feedback, but the final project is a lot more independent than the guided sprint. The result of a final project would be a storytelling website with D3. The first example that you can see here on the right is a project on characters in the Marvel universe and how they are interconnected. The final example I want to show you is for online classes. What we do here for guided sprints is to use Zoom breakout rooms at the end of a class. And we typically tell each group to work in a Google Doc where they can upload their sketches and can leave comments on each other's work. We've used design sprints for several years now and in many different settings, and throughout all of this we've learned some valuable lessons. So first, active learning must actually be taught to students. So they do not necessarily appreciate active learning at the beginning, because suddenly students have to become more active in class than they're used to be. Second, a project mentor is essential for consistent immediate feedback. It is really about pointing out flaws and ineffective visualizations to students quickly so that they can iterate on their work. Next, clear and written instructions are really essential for online classes. Online students have it much harder in that they cannot just walk up to you after class or quickly ask the neighbor if they missed something. So it's really essential that they have very clear instructions. Different prototyping tools allow to adjust difficulty in a design sprint. So depending on your student background and the length of your course, you might want to use just pen and paper, Tableau, D3, or any other programming environment or visualization environment that you use in your classes. Maybe one drawback of design sprints is that students tend to shy away from more creative solutions. Since it's a very guided process sometimes, where we stress good visualization designs, we've seen that sometimes students need to explicitly encourage to come up with solutions that are a little bit more out of the box in visualization design. Our takeaways for using visualization design sprints are: students can immediately apply what they learn in class, for example, design principles, toughness principles. Furthermore, projects adhere to better design guidelines, at least in our experience. So here's another example from a final project in our class where students visualized squirrel sightings in Central Park in New York City. And this is really made possible by this constant and direct feedback and iteration on their visualization designs. And finally, student engagement is high, and also project quality tends to be high. Thank you for listening, and make sure to check out our teaching material online.